Morning, Year 7. Miss Bishop here again. So, I am doing for you a little bit of climate change. Now, you're going to do this in Year 8 when you come back in September. So, the ones of you that do listen to these lessons will probably have to sit through this again. However, climate change is a tricky little thing to grasp. So, why not start it now? So what I want you to do is think, let me get rid of this. Why is the Earth warming up? So I want you to write down 5 causes that you think are affecting the environment in a negative way. So what 5 things can you think of that might be affecting the Earth, making it either warmer or colder? Okay, we'll go through some of these in a minute. But I want you to spend 5 minutes, 10 minutes, have a little think, ask whoever's at home, why do you think the Earth is getting warmer? What 5 reasons can you think of? There are loads, but if you can't think of 5, give me 3. Okay? So pause the screen, have a go at doing this, and we'll move on. Right, so causes, okay, we could have increases in pollution, so the use of cars and transport using planes and things like that. You could also have deforestation, so cutting down trees is a very big cause of climate change. You could talk about fires and increasing fires and letting off chemicals and carbon dioxide into the atmosphere, which is going to thicken that ozone layer and make it warmer, which means that the sea levels rise because ice caps are melting. You could say that using electricity and fossil fuels is a reason. You could also talk about cows and farming. We'll look over these. So cows let out a lot of gases by their just bodily functions. I'll let you fill in those blanks. They let off a lot of methane, and that is causing climate change. So we're going to have a look at that in more detail. So it says here, come up on your tables. Now, this is because this is taken from the lesson, and I didn't see this. So what I want you to do is come up with a definition for climate change, and I want you to come up with a definition for global warming, okay? No pride pounds, because obviously we're virtual and I don't know who's reading out what. Okay, so just spend 5 minutes. Come up with a definition for climate change and global warming. They are actually different things. Okay, they're not the same thing. They are slightly different. And in a minute, I will put up the correct answers. Okay, so please come up with your own definition, because the only way you will learn is if you practice. Okay, practice makes perfect. So pause the screen, have a go, and then I'll put up the answer. Right. So, can you please make a simplified version of this? If you just want to copy it out word for word because you think simplifying it will be too difficult, fine by me. I want you to get these down though. So climate change is the general change in trend. Trend is a pattern over the Earth's climate over many years. So climate change is how the pattern of Earth's climate changes over many years. It's over 30 years. This can be getting warmer or colder. When it gets colder, it is known as an ice age. It can be natural or it can be man-made. Okay? So when it's hot, it's called global warming. When it's cold, it's called an ice age. Global warming is the warming of the Earth's temperature year on year. So each year it gets hotter and hotter and hotter. Generally, each year the Earth is getting hotter. This is mostly a man-made issue, which we need to try and stop or reverse. Okay? So write those down for me. Okay. Now, we could be making this up and not actually know that the Earth is getting warmer. Now, we need to study these and understand these, okay? Now, when I went to university, I studied geology, which meant we had to look at the past. I did the ultimate history degree. Rather than looking back a couple of hundred years, I looked back millions of years. And you can tell by looking at ice cores and bits of particles that are captured in rocks and things, what the Earth would have been like temperature wise. Okay, so the Earth has cycles in it. So it spins round, doesn't it? The Earth spins round the sun. Every now and then it has a change in its orbit. So it will go from a circular orbit to a more elongated egg-shaped orbit. Don't worry about these now. Please don't worry about these now. We will do these in September when we come back. Okay, so I think it's after October we will do this. These are called the Milankovitch cycles. It says here we will look at these next lesson. We won't. We will look at these in October. So you can look at the past by looking at rocks and ice cores and things like that. Okay, so we can tell what the temperature would have been like because you can look at the amount of carbon present in these ice cores, and there's a certain type of carbon that you look for, and if there's a high concentration in it, you know it was quite warm. Okay, so this graph here looks, well, it looks complicated. It isn't. Okay, down here, all right, down here we have levels of oxygen. Now, oxygen has different isotopes, okay? This one is oxygen 18. This is the one that you can find in samples. Don't worry about that. So we've split this graph up into different time periods. You can see here, along here, we've got dates. Some of them are minus, some of them aren't. The minus ones are BC. The ones that aren't minus are AD. So if you could see here, we've got minus 54 and then 118. So if you think year zero, yeah, when Jesus was born, is probably about there. Yeah, he was born in when Roman Empire was, rife. So we've got here the ancient Egypt. We've got Greece. We've got classical Greece. Got Rome, the Mayans, the Vikings, the medieval period. You've got sort of Victorian times, and then you've got us now. Okay, so these different colours just dictate different time periods. So back in when ancient Egypt was around, when they built the pyramids, it was relatively hot. You can see here that the temperature is quite high. But as you then go down like a couple of hundred years, move along a couple of hundred years, the temperature starts to go down. And then it starts to go up again in the Greek Dark Ages. And then it kind of does a little bit of can't deciding what it's going to do. And then at the start of the Roman Empire, 2,000 years ago, with all the gladiators and whatnot. Oh, where's my mouse gone? There it is. It was very hot, generally, across the globe. And then, at the fall of Rome, it was quite cold. We had a cold period, okay? And then as we got into, like, when the Vikings invaded, the Vikings invaded us a couple of thousand years ago. Maybe not that long, maybe 1,500 years ago. Oh no, it's 800 something there. Yeah, it was quite a few years ago. It was cold. And then as we got into the medieval period, okay, now when we're talking like medieval period, you're talking like War of the Roses and like the Battle of Hastings, that sort of medieval period, quite early medieval, not sort of Tudors and Stuarts. That's further on here, okay? But it was very warm during the medieval times, okay? And then when you get to sort of Henry VIII and Queen Elizabeth and Queen Victoria and all the King Georges, it was very cold. I'm giving you like a history lesson here, aren't I, as well as a geography lesson. And we went through something called a little ice age. Now, back in the day, in the Victorian times, the Thames froze over. They used to hold markets on the Thames because it had frozen. And then you come out of the Victorian age, you could see it rapidly shoots up here. This might be because of the Industrial Revolution and things like that. So at the moment, we are currently in a warm period. Now, we are not in the warmest period we have been in, because if you see, me again. If you see, in the Roman times in ancient Egypt, it was actually a lot warmer. Okay? So, this leads to something called the greenhouse effect. Now, how many of you have been in a greenhouse? If you haven't, it's like walking through a sauna. Okay, strike that. When you've been in a bath or a shower and it's really hot, steamy, that's what it's like. A greenhouse is a very warm room in your garden. It's a little building made of glass. Okay. They're very hot. You grow sort of tomatoes, cucumbers, certain things in it. You sometimes get them at garden centres as well, but they're just very, very warm. Very warm. And they trap heat. The point is that the sun's rays and the heat goes through the windows and then it gets trapped in there to keep it warm. Okay, so you can see here that we have got our greenhouse. Okay, this is our greenhouse. This structure here is made of glass. You can see that the sun's rays, these yellow ones, go in through the windows. Now, some of them escape, but a lot of greenhouses have like this white, it's not a paint, but it is kind of like a paint on the windows. Now, that is to protect them and to reflect the sun's rays back into the room so they don't escape. So you can see that here. So the sun's rays bounce into the greenhouse and then they're trapped in there. And that makes it warm. Okay, it makes it warm. Very warm. It's about 10 degrees warmer in there, 20 degrees warmer in there than what it is outside. So in the summer, they get very, very hot. And it's very, very good for tomatoes and cucumbers. Okay. So, I want you to make notes. And you'll need to explain this in your own diagram. So the greenhouses trap heat from the sun. The glass panels let in light but keep the heat from escaping. They trap that heat. And this causes the greenhouse to warm up, okay? So you can see that this is what it's like in a greenhouse, which might be in your garden. And then you've got it with the earth. Now, imagine that the atmosphere, okay, this white cloudy bit here, is the greenhouse glass. Okay. Now, the thicker you make this due to pollution and climate change, the thicker this gets, the harder it is for the heat to escape. So the sun's rays, its heat, goes through these because it's really nice and strong because it's just come straight from the sun, so it's really strong. Okay? It can pierce through that atmosphere, that layer of atmosphere, that layer of chemicals. But that takes energy away from it. And then it gets a bit weaker. So what happens is it can't actually then escape back out again. So it just bounces around underneath this chemical blanket. And that is what causes the temperature of the Earth to rise, because that heat cannot escape back out into space. So it just keeps continually heating up. It's like if you have the sun shining in a classroom and we don't open those windows to let some of the heat out, how hot does it get in those classrooms? It is very similar. So the heat is coming through the windows and through the school, but if we don't open up those windows to allow that heat to escape, the temperature in the classroom just keeps getting hotter and hotter and hotter. So what I want you to do is have a go at drawing out this diagram. Okay, you've got the sun here. You've got the sun's rays are these dots and arrows. This bit here is the ozone layer, okay, that layer of atmosphere. And you can see that the sun's rays go through. Some of them do come out, some of them do, but a lot stay behind. So you can see here that the sun's rays have pierced through that chemical blanket, the ozone layer, but they can't escape and they just keep bouncing around, and that heat just gets trapped, and that causes the temperature to rise. So can you draw your own diagram and try and explain this? What I want you to do now, okay, is have a look. If you know your target grade, you can do purple if you know you are predicted a grade 5 to 9. If you're not and you just fancy an easy day, we're going to answer this question here. So, the bronze question. Some of the radiation from the sun, radiation means heat, some of the radiation from the sun is blank by the atmosphere, keeping the Earth warm, the blank effect. Gases in the atmosphere, for example, blank, blank, okay, and greenhouse gases are things like carbon dioxide, methane, which I've already mentioned, oxygen, and water, that contribute to the greenhouse effect are called blank, blank. Extra greenhouse gases in the blank have led to an increase in global blank. This is global warming. Climate change is a blank change in weather patterns. Now, all of the answers are here. So you've got long-term atmosphere absorbed carbon dioxide, temperature, greenhouse gases, and then you've got greenhouse here as well. Okay. So let me just change. Let me just move this along because it's just making it look like carbon dioxide should be. Nope, it's not going to work. Is it? Oh, are you crashing? Is it crashing? Yep, it's crashing. Oh, might just have to roll with it as it is. But carbon dioxide is one word, is like together. Okay, so it's two words, but they are together. But I'm just trying to move it along, but it's not working. Oh, no, it might do now. Oh, absorbed carbon dioxide. There we go. Okay, so what I want you to do is answer that. And then if you fancy doing purple as well, give 2 pieces of evidence other than changing global temperature to show that climate change has taken place. So give me 2 pieces of evidence other than the change in global temperature to show that climate change has taken place. We could be talking about things like increase in sea levels. We could talk about ice caps melting. Yeah, think of the polar bears. Think of the coral reefs that we looked at. Yeah, have a go. All right. And then to finish off, I want you to just think about the differences between global warming and climate change. Okay. I will speak to you next week. Have a lovely week, and I will do another lesson for you then. Bye.